Okay, so hello everyone. I hope I'm audible and screen is visible. Yeah. Good morning, one and all. Please confirm. Am I audible and screen is visible? Okay. Chaliye. Chaliye. So now let us start with where we left yesterday. No, so we left yesterday at a question, no, where we have to do the we have to find the precision, recall, accuracy for a multi-class data set. Okay, for a multi-class data set we have to find the precision, recall, accuracy, everything, right? Chaliye. So now firstly I'll just write the formula how to calculate precision, recall, accuracy. Okay, so guys, just note down the formula, right, for multiple samples, no, for multi-class. So this is for multi-class. Okay, for multi-class I'll just write for multi-class I'll just write the formula for precision. So precision is defined as precision for multi-class, that is defined as, okay, precision for class I. For example, we have 3 classes, right? So for 3 or for any number of classes, so precision for class I, so that would be defined as number of samples predicted as true positives for class I. Okay, number of samples predicted as true positive for class I. Okay, for class I, number of samples predicted as true positives for class I divided by, okay, divided by total number of samples predicted with I. Okay, divided by total number of samples predicted with I. Okay, total number of samples predicted with I. Okay, so this is precision for class I, and just write the recall formula. Okay, recall for class I, so that is total number of samples predicted or true positive, no, for class I. So recall is what? Again I'll just write recall for class I. Recall for class I, what is that? It is total number of samples. Okay, that is what? That is total number of samples predicted as true positive for class I. Total number of samples predicted as true positive for class I. Okay, upon total number of actual samples. Okay, total number of actual samples present in the training data. Okay, with actual label I. Okay, total number of samples present in the training data. Total number of samples present in the training data with actual class I. Okay, with actual class I. So this is how precision and recall. Okay, this is how precision and recall is defined. Okay, this is how precision and recall is defined. Okay. Yes, Newsbuster. Yeah, I'll do this better. I'll do this. I have to cover that cost function also, and cross entropy loss also. Okay, that is known as log loss. Definitely I'll do this. Okay, so firstly just do certain numericals on precision for multi-class. Okay, you should have a knowledge of how multi-class problem is approached. Okay, yeah. करेक्ट, ये नेगेटिव क्लास के लिए भी कर सकते हैं. तो आई जस्ट टोल्ड यू फॉर क्लास आई, नो. तो हियर वी डोंट हैव दैट कॉन्सेप्ट ऑफ नेगेटिव क्लास. ओके, तो आई विल जस्ट डू वन क्वेश्चन. ओके, विल डू दिस, विल डू वन क्वेश्चन. ओके, तो जस्ट वेट फॉर दैट. Everything would get clear, no worries. Okay, we'll do one question. Done, 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 done. Chaliye, just write the formula quickly, then let us start with certain questions. Okay. Okay, chaliye, now solve this question. So this is a question where we have three classes. Okay, urgent, normal and spam. We have three classes: urgent, normal and spam. We need to calculate precision and recall for urgent class, precision recall for normal, precision recall for spam, and the accuracy. Okay, try this. Okay, try this. Okay, so just try this. How to solve it? I'll just give you a minute. Okay, firstly just try it, then I'll do this. Okay, now let's see how to do this. So I want to calculate precision. Okay, I need to calculate precision for class urgent. Okay, so this is precision for class urgent. Okay, now what is the definition of precision for class urgent? Very simple. Okay, definition is very simple, that true positives, right? True positives actually predicted, actually urgent, predicted also urgent. That is how much? That is 8. So here I would just write 8 upon up. Now here predicted urgent, how many are there that are predicted urgent? That is 10 plus 8 18, and 18 plus 1 19. Okay, so with predicted urgent, that is 19, right? And okay, and what is recall? And what is recall here? Recall for class urgent. Okay, recall for class urgent, that is what? Yeah, what is recall here? Very simple. Okay, recall is the true positives, that is 8, and with the actual before training data set, the actual data set urgent, total number of samples with actual data set urgent. Okay, total number of samples with actual data set urgent. Okay, so there what are the total number of samples with actual data, with actual class label urgent? So those are 8 plus 5 plus 3. Okay, I hope you are getting this. So this summation is how much? That is 8 plus 5, yeah, 13 plus 3 16. Okay, so that would be how much? It would be 16. So recall for class urgent would be how much? It would be 16. Okay, recall for class urgent would be how much? That would be 16. Similarly precision for the class normal. Okay, similarly precision for the class normal, that is how much? Yeah, very simple. So I can just write precision for class normal, that is true positives, so that is 60. Okay, 60 for normal, predicted also 60. Okay, actual normal, that is and predicted normal, that is 60. Okay, so this would be how much? 60 upon total predicted normal. Total predicted normal is how much? 65 plus 50. So that would be, yeah, 60 plus 50, 110 and 115. Okay, so this would be 115, right? And what is the recall? Okay, what is recall for class normal? Okay, what is recall for class normal? So recall for class normal is how much? That is recall for class normal, वो कितना आ जाएगा? तो true positives, what are the true positives? That is 60 upon actual class normal, that is how much? 60 plus 30, 90 plus 10, that is 100. Okay, similarly I need to calculate the precision for the class. Okay, precision for the class spam. Okay, precision for the class spam. Okay, precision for the class spam, so that is how much? Yeah, so this precision for class spam would be 200. Okay, so this would be 200 upon predicted spam, how many? That is 233. Okay, 200 upon 233. And recall, yeah, so I would guess, yeah, I would just calculate recall for the class, recall for the class spam. Okay, recall for the class spam is how much? Yeah, so that would be correct, that would be how much? True positive, that is 200 upon actual spam. Okay, that is how much? That is 251. Okay, so 200 upon 251. So this is how we solve the questions for multi-class data set. Okay, this is how we have to solve the questions for multi-class data set, right? This is how we have to solve the questions for multi-class data set. Okay, and what is the accuracy? Very simple. How to calculate accuracy? So accuracy is how much? Accuracy would be, this is part C. Okay, what is accuracy? True positives. Okay, so true positives for all the three classes, that is 8 plus 60 plus 200. Very simple. Okay, so you just have to focus on concepts, right? Just focus on concepts. 8 plus 60 plus 200. Okay, that is how much? 8 plus 60 plus 200 upon, okay, upon 8 plus 60 plus 200. Okay, upon 8 plus 60 plus 200. Okay, upon then the total number of samples in the data set, right? So that is 10 plus 8 plus 1. Okay, so I would just write 10 plus 8 plus 1. Okay, then 5, 60, 50. Then we have 5, 60 and 50 plus then 330, 200. Okay, 330 and 200. तो ये आपकी आ जाएगी accuracy. Okay, तो this would be how much? This would be 268 upon total sum करके देखो कितना आ रहा है. Total sum would be how much? I'll just do the total sum. हाँ, 367, correct. So that would be 367. ठीक है. So total sum would be how much? This would be 367. So this is how we have to calculate accuracy. Okay, this is how we have to calculate accuracy. So never forget this concept of accuracy in case of a multi-class data set. Okay, and guys, I'll tell you very important note. Okay, just note it. Okay, I'll just note it down. Just note it down, very important point. Accuracy is never calculated. Accuracy is never calculated in a imbalanced data set. Okay, accuracy is never calculated for imbalanced data set. Okay, for imbalanced data set, accuracy is never calculated for imbalanced data set. Okay, accuracy is never calculated for imbalanced data set. Okay, and instead, because it leads to misleading accuracy, because it leads to misleading accuracies. Okay, it leads to misleading accuracy. Okay, it leads to misleading accuracy. And always ROC AUC curve. Okay, ROC AUC curve gives the reliability. Okay, gives the reliability of the model. Okay, reliability of the model. Okay, so AUC ROC curve gives the reliability of the model. Okay, AUC ROC curve gives the reliability of the model. Okay, it gives the reliability of the model. Okay, so you just write it, and next topic would be AUC ROC curve. Okay, that would be AUC ROC curve. Okay, just write it. Okay, chaliye, now let us start with the new topic, that is AUC ROC curve. Okay, this question is for homework, very simple, multi-class precision, recall and accuracy for multi-class data set. Okay, so this you would be doing as the homework. Okay, and again this question as homework for you, this you will be doing as homework. Okay, then let us now focus on AUC ROC curve. Okay, now let us focus on AUC ROC curve, right? Acha, now firstly, what is imbalanced data set? I'll just tell you what is imbalanced data set. So imbalanced data set is, for example, I'm training a model. Okay, for example, I'm training a model. For example, I have a data set. Okay, and I am training a model for people who have COVID and who doesn't have COVID. Okay, so in the target variable, for example, a total of 1000 samples are there. Okay, so among this 1000 samples, among the 1000 samples, okay, so among this 1000 samples, so in the target variable, if 999 samples, okay, if 999 samples are COVID positive, okay, I have two classes. Okay, I have two classes. The first class is COVID positive, okay, and the next class is COVID negative, right? The next class is COVID negative. So these are the two classes in the target variable, right? So for example, while training the data set, I have total 999 samples as COVID positive, okay, and only a single sample is there that is COVID negative. So don't you think that the model would be more biased towards COVID, positive samples? Don't you think that the data set would be more biased towards COVID positive samples? Bhai, yahan par while the training the data set, no, majorly it would be trained on this COVID data set. So it would actually be learning only the traits or the features of what? COVID positive samples, because only we have a single sample of COVID negative. So that is a highly imbalanced data set. Okay, this is known as a highly imbalanced data set. So this is known as imbalanced data set. Okay, so in this case, we never calculate accuracy. Okay, in this case, we never calculate accuracy. So that is why it is always said calculate precision, recall, accuracy, F1 score, ROC, AUC curve, other things, but never calculate accuracy, because that could be misleading. Very important point, highly asked in the interviews. Okay, that is highly asked in the interviews. Okay, chaliye, now next topic that I would be covering is AUC ROC curve. Okay, AUC ROC curve, the full form is receiver operating characteristics, and the full form of AUC is area under the curve. Okay, full form of AUC is area under the curve. Okay, chaliye, ab now if you just see here that I want to evaluate how reliable a model is. Okay, I want to evaluate how reliable a model is. Okay, I want to evaluate how reliable a model is. So that can be calculated by drawing a graph between true positive rate and false positive rate. Okay, so it is calculated by drawing a graph between true positive rate and false positive rate for every data point. Okay, so for each data point, for every data point, we actually draw a graph between true positive rate and false positive rate. Okay, and this curve, and this, I mean the area under this curve, for example, this is the curve. So area under this curve tells us the score, okay, or tells us the AUC score. Okay, so this area under the curve, okay, area under the curve, this curve tells us the AUC score. ये क्या बताएगा हमको? It would tell us the AUC score, and higher the AUC score is, higher the area under the curve is, more reliable the model is. This understanding you should have. Higher the AUC score is, more reliable the model is. Okay, higher the AUC score is, more reliable the model is. So this is how the AUC ROC curve is designed. Okay, so for every data point, combinedly, for every data point, I draw a curve between true positive rate, false positive rate. What is true positive rate? That is nothing, that is known as sensitivity. Okay, and what is false positive rate? That is nothing, that is known as specificity. So a graph is drawn. A graph is drawn between true positive rate and false positive rate, and more the area is, more reliable my model is. Okay, I hope आप समझते हैं reliability. What is reliability? हिंदी में क्या बोलते हैं reliability को? Reliability को बोलते हैं कि it is कितना भरोसेमंद है, मतलब प्रीवियसली कितने इसने सही आंसर्स दिए हैं, हाउ प्रेडिक्शन गुड वाज ऑफ दिस मॉडल, तो दैट इज बेसिकली रिलायबिलिटी. ओके, तो इट इज ऑब्जर्व्ड दैट मोर द AUC इज, आई मीन मोर दिस curve area is, more reliable the model is. So that is why it is also one of the metrics that you should learn. Okay, that you should learn that yes, कि more the area would be, more reliable the model would be. Yes, तो मतलब for IPL matches for example, I want to make a win predictor for IPL match, no, तो if at all we don't have if at all we have an imbalanced data set, no, for example matches for RCB are less, matches for KKR are more. Okay, though we have an imbalanced data set, but if ROC AUC score is high of that model, no, so I can still trust, yes, that this model would predict good on the unseen data. So there is how, I mean, that is how this also matrix is calculated along with accuracies and other precision matrix. Okay, so this is how, yeah, sensitivity, specificity are designed. Okay, now I would just tell you what exactly AUC of AUC 0.5 means. Okay, so this is AUC 0.5. So what this AUC 0.5 means, that for example if you ask me by incoming next IPL between KKR and Rajasthan Royals, who would win? Okay, if you just ask me for the coming match between KKR and Rajasthan Royal, who would win, so I can randomly say, because I am just a learner, no, how would I know, how would I know, I am just a learner. Okay, I am just a viewer, so I can randomly say that okay, KKR would win, okay, or okay, Rajasthan Royal would win. So what is my AUC score? My AUC score is 0.5. Okay, what is my AUC score? My AUC score is 0.5 because that is a random guess that I am actually guessing it. Okay, that is just a random guess that I am actually guessing it. Okay, so what is my AUC score? That is 0.5. My AUC score is what? 0.5. Okay, now if I train a model on previous 10-12 years data, okay, jitna bhi hoga, matlab for example I have 10 years data, so if I train the model for the previous 10 years data for Rajasthan Royal and KKR and then I make a win predictor, so there actually model can predict better than me. Okay, there actually model can predict better than me. So here AUC score would be more than 0.5 and let us suppose that AUC score is 0.65. So that means the model is 65% reliable. Okay, or model is 65% trustworthy. I hope you are getting this. Okay, and for example if AUC is close to 1, so if AUC score is close to 1, that means AUC score is 0.93. That means the model is 93% reliable. That yes, in 93% cases, it would give us right prediction, or it would give us close predictions or correct predictions. Okay, so this is how AUC ROC score is modeled. Okay, this is how AUC ROC curve is designed. So that means कि if AUC is 0.5, मतलब वो तो मैं ही हूँ, I am AUC 0.5. Okay, this is me. This is a random guesser. Okay, तो this AUC 0.5 मतलब ये मैं हूँ. This is me. Okay, this AUC 0.5 मतलब ये मैं हूँ. Okay, I am a random guesser. This is also getting randomly. Okay, अच्छा, अब यहाँ पर if score drops less than 0.5. Okay, now very important thing, if score drops less than 0.5, then what would happen? मतलब भाई ये तो मेरे से भी गंदा बता रहा है. I hope you are getting this. If AUC score drops less than 0.5, मतलब क्या कर रहा है भाई, ये तो मेरे से भी गंदा बता रहा है. That means कि रोहित शर्मा is hitting sixes. Okay, अब जैसे मान लीजिए इंडिया पाकिस्तान का I want to make this win predictor. Rohit Sharma is hitting sixes and model is saying India would lose. I hope you are getting this. Okay, I hope you are getting this. तो AUC is as much AUC is close to 1, मतलब जितना भी ज्यादा close होगा 1 के, okay, more the AUC is close to 1, more reliable, trustworthy the model is. So in the majority of the unseen data, it is more, the probability is more that it would give good prediction. So this is how AUC score is modeled, or this is the significance of AUC ROC curve. Okay, so what is ROC? ROC is receiver operating characteristic, and what is AUC? That is a score. That means that is a score that is actually obtained between from this the graph that is modeled between true positive rate and false positive rate. Okay, so you should have this understanding. If AUC is less than 0.5, मतलब ये तो भाई मेरे से भी गंदा बता रहा है. Okay, so that means AUC should be between 0.5 and close to 1, more than 0.5 and close to 1 for actually for a good or reliable model. Okay, so if model has lower than 0.5, which means that it performs worse than a chance. Okay, it performs worse than a chance. Okay, and perfect model has an AUC score of 1.0. Okay, perfect model has a AUC score of 1.0. This you should remember. Okay, so while studying, just make a short note, keep 3 to 4 pages along with you, staple it, and just write the simple point regarding AUC ROC. Okay, so this I expect everyone, okay, every one of my students should do this. Okay, this would definitely help you a lot. बेटा बहुत आपको मदद करेगा, जरूर ये प्रैक्टिस अपनी करना, ठीक है, for coming 90 days. ठीक है, done. तो this is how AUC ROC score is model. तो आप बना लीजिए, you just draw all these cases. Okay, please draw these cases. Okay, I'll just wait for a minute. Okay, and draw the next graph also, it would help you a lot. Okay, just draw this graph also, it would help you a lot बच्चा. तो इसको भी बना लीजिए. Okay, now next is log likelihood function. Okay, next is log likelihood function, important in case of, yeah, that is important in case of logistic regression. Okay, so I'll just write it here. Okay, I'll just write it here. One important concept, that is log likelihood function. Okay, so in case of logistic regression, you should know the formula. Okay, log likelihood function, you should know the formula for this. Okay, if at all question comes, calculate the log likelihood function, you should know the formula. Okay, now it is a function that tells us how likely the data is under current model parameters. Okay, okay, so it tells us how the data yeah, it tells us how likely the data is. So what likely means, I'll just tell you how likely the data is. Okay, how likely the data is under current parameters. Now here, what does this likely means? What exactly this likely means? I'll just tell you. Okay, likely means how better the model is, model can fit to this data. Okay, what likely means is कि कितना अच्छा model, कितना अच्छा data fit हो सकता है इस model के through. Okay, how better, okay, how better or best the model can fit the data. Okay, I hope आप समझ पा रहे हैं कि for example if I just give a non-linear data, no, for example in for logistic regression, okay, for an example I'll just write, for example, okay, for example if I give a non-linear data, okay, for example if this is the data, for example if this is it, this is x and this is y, okay, and this is the scatter plot, okay, this is the scatter plot of the data. Okay, this is the scatter plot of the data. Ab I hope you are able to see, no, कि after doing EDA, no, after doing EDA, I hope you are able to see, by this data is not at all likely. I hope you are getting this. By this data is not at all likely. मतलब that is not suited for fitting a logistic regression model because that is a non-linear data. Okay, this is what? This is a non-linear data. Okay, so this is not at all a likely data for logistic regression model. I hope आप समझ पा रहे हैं कि if you want to fit the data, we should have linear data, and with it two classes. Along with this only we should have two classes. Binary data should be there. Okay, भाई अगर मैं तुमको non-linear data दे दूंगा तो it is not possible to fit this data. That means this data is not likely. Okay, under current parameters. Okay, for this model under current parameters, this data is not likely. But this you should remember. This understanding you should have. Okay, so for this only we calculate log likelihood function. Okay, for this only we calculate log likelihood function. So the formula for log likelihood function is, that is summation of I equals to 1 to n. Matlab for all the data points which I have, I would be calculating yi log. Okay, and this is I'm writing for binary class. Okay, yi log yi yes, yi log yi hat. Okay, yi log yi hat plus 1 minus yi log 1 minus yi hat, and this is done for the entire data. Okay, this is done for the entire data which we have. Okay, this is done for the entire data which we have, right? I hope you are able to guess what is yi. Okay, I hope you're able to guess what is yi hat and yi. So what is this yi? This yi is actual class. Okay, what is this yi? It is actual class. And what is yi hat? This is the predicted class. Okay, this is the predicted class. So if at all question comes to calculate the log likelihood for this data, so this is how we need to calculate it. Okay, this is how we need to calculate this. So it is always said that if you have a nonlinear data, never fit a logistic regression model. Okay, just write it. If you have a nonlinear data or a multi-class data, never fit a logistic regression model. Go for what? Go for either decision tree or random forest, that we would be covering today. Okay, that we would be covering today. It is always said, if we have a nonlinear data and a multi-class data, it is advisable, don't go for logistic regression model. Okay, so this shouldn't be seen, आपने data देखा, उठाया, scikit-learn लगा दिया, गलत, ये कभी नहीं होना चाहिए. That is why it is always advisable that perform EDA. भैया EDA करो, तभी पता चलता है, then only you get to know how the data is behaving. Okay, what the data is. Or data scientist, data engineers, data analyst, the main role of this is to actually gather the behavior of the data. How the data is actually behaving, that actually is the main function of a data scientist, analyst to gather. Okay, because applying a library is very simple. Okay, applying a library is very simple. भाई कोई भी कर दो, anyone can apply library. Scikit-learn आपको लगाना है, and you just have to import the classifier, DT tree. Okay, very simple. No, just use scikit-learn stats model or API library. You can just fit the data. But before fitting, you should always perform EDA. That would tell you how the data is, how the behavior of data is. And it also involves number of statistical concepts. अभी तो हमने सिर्फ gate का, we are only focusing on the gate concepts, but we have number of more statistical concepts. But it is very interesting. Okay, it is very interesting. Once you just go deep in this field, no, this field is very interesting and highly paying field. Okay, चलिए. So this is the log likelihood function. Okay, log likelihood function for a binary class data. Okay, this is a log likelihood function for a binary class data. And what is n here? Just write n. N is number of data points. Okay, what is n? N is number of data points. Yes, you only tell me. Yes, Newsbuster, you only tell me what is yi hat. Why, for logistic regression, what is the prediction? Very simple, no? What is yi hat? So yi hat is what? That is the probability, no? You won't be getting a number. Here you would be getting probability for that class. So that is what? That is sigma z, 1 upon 1 plus e to the power of minus z. So there you get the probability in case of logistic regression. I hope you are getting this. In case of logistic regression, you would be getting the probability, no? That is the nature of logistic regression. So this is for logistic regression. I hope you are getting this. Okay, that is for logistic regression. You would be getting the probability, not in case of class, so you would be getting the probability in continuous numbers, and based on that number you would be deciding whether it belongs to COVID or no COVID. Okay, chaliye, so let us do one question. If you are facing doubts, let us do one question. So I am giving you a data set, a very small data set. Okay, one question for you. I am giving you a very small data set, only 3 entries, right? Only 3 entries, and calculate the log likelihood function. So this is x, this is y. Okay, so when x is 0, when x is 1, and when x is 2, we have classes as 0, 1, 1. Okay, so these are the classes given, and the learning parameters are given. Okay, the learning parameters for logistic regression model. Okay, learning parameters for logistic regression model. Okay, learning parameters for logistic regression model, m and c. Okay, these are given, right? M and c, these are given. What is the value of m? That is -1. एक मिनट में देख लेता हूँ. m, c is -1 and m is 2. Okay, these are the learning parameters given. चलिए, calculate the log likelihood function. Calculate the log likelihood function. Everyone, calculate the log likelihood function. So what is log likelihood for this? So it is a binary class data set. I hope you are able to see this. This is a binary class data set. I hope you are able to see this. Binary class data set. Okay, I hope you are able to see this. This is a binary class data set. How to do this? Very simple. Everyone should do this. Okay, very simple, no? That you have to just use what? The formula summation of I equals to 1 to n for the entire data set. So we have 3 points here. Okay, and what is the formula? This is the formula, yi log yi hat. Okay, yi log yi hat. Okay, plus 1 minus yi. Yes, plus 1 minus yi log 1 minus yi hat. Okay, plus 1 minus yi log 1 minus yi hat. Okay, this is the formula that we have. So firstly calculate this for x equals to 0. For x equals to 0, x equals to 1, x equals to 2. So just calculate what? yi. Okay, so y1 hat, yeah, calculate y1 hat, then calculate y2 hat, and calculate y3 hat. So what is y1 hat? Very simple, no? y1 hat is what? 1 upon 1 plus e to the power of minus 1 upon 1 plus e to the power of minus. Okay, yeah, 1 upon 1 plus e to the power of minus. Okay, minus 2 into 0. 2 into 0 minus 1. Okay, 2 into 0 minus 1. Just calculate this probability. Then similarly here also 1 upon 1 plus e to the power of minus 2 into 1 minus 1. Okay, and just calculate y hat 3. So similarly calculate y hat 3. Okay, all the probabilities you calculate. So you'll be getting 0.2689. This is 0.2689. Okay, the next is 0.7311. 0.7311 and y3 hat, that you would be getting as 0.9526. Okay, this you would be getting as 0.9526, right? But now what you have to do, you have to just put here. Okay, you have to just put it here. Okay, you have to just put it here. Tell me the value, how much you are getting. So for 0.1 calculate this thing, for 0.2 calculate this thing, for 0.3 calculate this thing, and just sum up and just tell me the answer. Okay, calculation would take time bacha, calculation would take time. Okay, न्यूज़बस्टर कैलकुलेशन बच्चा, इट वुड टेक टाइम ये लॉग लाइकलीहुड में, बट ट्राई टू डू दिस बिट फास्ट विद अटमोस्ट एक्यूरेसी, है ना? तो टाइम तो लगेगा बच्चा आपको इसमें, कोई बात नहीं, कोशिश करो. Okay, so you would be getting minus 0.313 for the first data point. Okay, I'll just write for first data point, for x equals to 0 and y equals to 0. Okay, for x equals to 0, y equals 0. So log likelihood is how much? So this you would getting as, yeah, for this you would be getting answer as negative of 0.313. Okay, negative of 0.313. Okay, similarly for x equals to 1, y equals to 1. Okay, for the second point, x equals to 1, y equals to 1, and third one is for x equals to 2 and y equals to 1. So yeah, so this log likelihood we are getting it as, okay, so we are getting it as negative of 0.313. This is again negative of 0.313, and the third one is negative of 0.0485. Okay, negative of 0.0485. So summing up all the things, so total log likelihood, no, so total log likelihood, how much it would be? So I would just sum all these three, so I would be getting negative of 0.674. Okay, negative of 0.674. Okay, so guys, it would take time, just don't worry. I just wanted you to give the concept. I want to show how a calculation would take place. Okay, just don't worry. So just write it and after the class solve it, okay, yourself, right? And if you are asked to calculate negative log likelihood function, no, if you are asked to calculate negative log likelihood function, so basically what negative log likelihood function is, we just have to apply a minus. Okay, so what is negative log likelihood function? So I'll just write negative log likelihood function. Okay, negative log likelihood is nothing, I just have to apply a minus before that formula. Okay, so this is yi log yi hat plus 1 minus yi log 1 minus yi hat. Okay, so this is negative log likelihood, right? This is the formula for negative log likelihood, where what is yi, I told you, no, yi is what? This is actual data. Okay, actual class label. Okay, actual class label. Okay, what is y hat I? That is predicted class label. Okay, y hat I is predicted class label. Okay, and what is n? N is total number of data points. Okay, this is n, total number of data points. So just a negative would be added. Okay, just a negative would be added. Okay, so what is the significance of this? Already I have told you how likely the data is. Okay, how likely the data is. So that actually tells us the log likelihood function. So if it is positive, so the more likely the data is, and negative log likelihood is the reverse of I mean likelihood. Okay, how unlikely the data is, just nothing. Okay, only this thing is there, ज़्यादा कुछ नहीं है दोनों में. कभी कभार क्वेश्चन आ जाता है नेगेटिव लॉग लाइक्लीहुड का, तो बस मैंने आपको फॉर्मूला बता दिया, वी जस्ट हैव टू ऐड अ नेगेटिव फंक्शन. तो दैट इज हाउ अनलाइकली द डेटा इज, बस और कुछ भी नहीं है, नथिंग एल्स. ओके, नथिंग एल्स. तो it is just how unlikely the data is, बस और कुछ नहीं है. Okay, so you should just know the formula. At times questions are there. Okay, and intentionally I have given questions in the test series for geeks no, मैंने काफी सारे question दिया है, तो क्योंकि important है, आया हुआ है. Okay, this is there. Okay, in the syllabus. Yeah. ओके, चलिए, तो this is all for logistic regression. Okay, this is all for logistic regression. Now I would be starting with the decision tree and random forest. Okay, so this is all for logistic regression from my side. I have given you certain question for homework. Do solve this. Okay, and today and now I'll be starting with the decision tree and random forest algorithms. Okay, okay, chaliye. Yes, yeah, Ranjan, I already told you, no, कि negative log likelihood is basically how unlikely the data is. So, for example, in a EDA, no, for while you are applying EDA, you have a data set with you. अब आपसे if anyone in the interview asks you which algorithm you would use and why, so how to justify that answer why? So if you are using a binary, I mean for binary data, if you're using logistic regression, so just answer him in this way, that the log likelihood of this data is very high. So that means logistic regression could be fitted here. Okay, that I can fit here. So this is how you have to answer it. Okay, this is how you have to answer it. Okay, yes, lucky cost function I'll be doing, but I'll just start this decision tree, then soon after that in the last I'll be doing that cost function. Okay, I'll explain you once more. Okay, no worries. Chaliye, ab now let us start with decision tree and random forest. Okay guys, do concentrate here. So this decision tree random forest, so this is highly suited for non-linear data. Okay, this is highly suited for non-linear data. Okay, तो अब जैसे एक we had a limitation, no, we had a limitation for with the logistic regression model that we can't use this for non-linear data. So for non-linear imbalanced data, okay, high dimensional data, so we have decision tree for that. Okay, we have decision tree for that. So I would just start the discussion on decision tree. I would just start the discussion on decision tree by introducing you it as a tree structure, okay, learning model to make future prediction. it is a tree structure. Okay, it is a tree structure learning model. Okay, it is a tree structure learning model used for making future predictions. Okay, it is a tree structure learning model used for making future predictions. Okay, used for making future predictions. Okay, चलिए, तो it is a supervised learning algorithm. Again, it is a supervised learning algorithm. Okay, it is a supervised learning algorithm. Okay, do write all these points along with me. Okay, and it is used for regression and classification problems. It is used for both. Used for both regression and classification. Okay, used for both regression and classification. Okay, it is used for both regression and classification. Okay, when data is non-linear, decision tree is highly used. Okay, decision tree is used when data is non-linear, decision tree is used. Okay, acha, it is also used with small to medium sized data set. Okay, used small to medium sized data. Okay, used with small to medium sized data. See, there is no I would not give you any measure to measure that this data is small or medium. Okay, generally it is said that with very large data we doesn't use decision tree. Okay, with very large data we doesn't use decision tree, but there is no measure to measure, I mean, what exactly, there is no reference for measuring, no, what is a large data, what is a small data. Okay, acha, it is also very good with imbalanced data set. Okay, it behaves very well with imbalanced data set. Okay, it also behaves very well with imbalanced data set. Okay, but the problem is this is prone to overfitting. Okay, the problem is it is prone to overfitting. Okay, one of the problem with this, it is prone to overfitting. It mugs up the data. ओके, ये क्या करता है, ये डेटा को याद कर लेता है, इट मग्स अप द डेटा. ओके, द मेजर प्रॉब्लम इज दैट इट इज प्रोन टू ओवरफिटिंग. ओके, इट मग्स अप द डेटा. ओके, तो यू जस्ट राइट सर्टेन इंपॉर्टेंट पॉइंट्स, देन लेट अस स्टार्ट विद द डिसीजन ट्री. Okay, now I'll start with one example. Okay, I'll just start with the example. Like, for example, imagine that you are working for a Hollywood film studio. Okay, now let us start with an example. For example, you are working with a Hollywood film studio. Okay, and your desk is piled with number of screenplays. मतलब आपके पास बहुत सारी movies हैं. Okay, you are working with a Hollywood film studio and you have number of movies. Okay, now we have three classes. Okay, here we have three classes. The first class is critical success. Okay, we have three classes in the target variable. The first class is critical success, the second class is mainstream hit, and the third class is box office bust. Box office bust is what? It is nothing, the movies which are flop. Okay, so it tells you that the movies which are flop, that is box office bust. ठीक है, तो मान लीजिए कि in the data set I have three classes. कौन कौन सा? First one is critical success, then second one is hit, the mainstream hit, the movies that are very that are hit, and the third one is box office bust, मतलब जो movies flop हो चुकी हैं. Okay, तो these three classes are there with me. Okay, these three classes of movies are there with me, and the sample set is of 30 movies. Okay, so how many movies are there? The sample set has 30 data. Okay, so this sample set has 30 data. Okay, 30 different movie scripts. Okay, so this sample set has 30 movies. Okay, so I would just write n is how much? N is equals to 30. Okay, n is how much? N is equals to 30. Now what I want is, I want to make a movie where I should select what? I want to decide which all celebrities I want in my movies. Okay, which all celebrities I want in my movies. Okay, and what should be the budget of the movie? Okay, what should be the budget of the movie to make it a mainstream hit? मतलब मैं किन किन हीरो हीरोइन को लूँ, which all hero heroines should be taken, which all celebrities should be taken, and what should be the budget of the movie so that this could be a mainstream hit. Okay, just try to understand this example. Okay, very interesting example, you'll really understand it. Okay, so what should be the budget and what should be the celebrity that I should take so that my movie should be a mainstream hit. Now what I would do is, instead of watching each and every movie script, okay, now what target is given to me is, instead of watching each and every movie script, now what I'll do is, I would try to make a scatter plot, okay, between number of celebrities and estimated budget. Okay, between number of celebrities and estimated budget. So how many celebrities were there along with the estimated budget? I want to make a scatter plot. Okay, what I want is, I want to make a scatter plot between the A-list celebrities and estimated budget. Okay, now what I would do is, now see what I would do is, I would try to homogenize. Okay, what I would do is, I would try to homogenize the nodes, okay, or the classes. अब मेरे पास, this is a scatter plot having 30 movies of different classes. I have 30 movies of different classes. Okay, अब what I would do is, now if I just make, okay, now what I'll do is, if I just make a line, okay, if I just make a line, okay, a rough line, okay, if I just make a rough line, yeah, for example, if I just make a rough line here, okay, if I just divide, yeah, if I just divide here and if I just select A-list celebrities, right, if I just, yeah, select A-list celebrities as the dividing or as the partitioning reference, okay, as the partitioning reference, so don't you think that box office bust category is almost separated? Don't you think that bust office category, bust office, yeah, box office bust, I mean flop movies are almost separated? Okay, so basically what I have done is, I have drawn a decision boundary. Okay, basically what I have done is, I have drawn a decision boundary where this category has been homogenized and separated from the entire decision tree. Okay, from the entire decision tree. So basically what I am doing in decision tree, I am trying to partition the data by drawing the linear decision boundaries such that my categories would be homogenized, and I would get, if I select these celebrities, if I select these number of celebrities, I am very sure that I would be getting a box office bust. Okay, try to understand the logic what I am telling you. Okay, if I select these all categories, I can be very sure, मतलब majorly I can be sure that भैया मेरी जो movie बनेगी वो मेरी flop ही बनेगी movie, because this feature have given me a reference point कि this decision boundary, I mean below this decision boundary, majorly I would be getting flop movies. And yes, inaccuracies, no decision boundary, no algorithm is 100% accurate. So I have one movie, I have one movie which is mainstream hit, okay, and I have one movie I mean just below this decision boundary, that is critical success. No algorithm is 100% perfect, no. So I can say that I haven't homogenized 100% of it, but maximum of it I have homogenized, okay. So I got this point. अगर मैं इससे कम वाले celebrity लूंगा, if I take the celebrity along these one, okay, if I take these celebrities, major probability is that I would be making a flop movie. Okay, so this is the first partition that I have drawn. Okay, so first split is based on what? First split is based on the A-list celebrity. Okay, first split is based on what? First split is based on the A-list celebrity. Then next split I would be making, where I would be making along the estimated budget. Okay, I would make along the estimated budget. So if I make next split, okay, if I make a next split here, okay, if I try to make a next split here, so majorly agar if I try to make the movie more than 10 crores or more than 15 crores, okay, so probability is high that I would be getting a mainstream hit. Probability is high that I would be getting a mainstream hit. And if I make a movie less than 10 crores, probability is high that I would be getting a critical success. As I told you, no algorithm is 100% accurate. So we have errors here also. No? We have error here also. That means I am not able to totally homogenize a class. Okay, no worries. Errors are everywhere. Okay, so one of the movie is included here. Yeah, one of the critical success is included in this partition. Okay, no worries. Let it be. ठीक है, तो but the major learning from here is that what I am trying to do is I am trying to split along the features. Okay, just try to understand this. How decision tree works? Decision tree tries to split along the features. ये features के along ये यहाँ पर partition बनाता है कि अगर तुमने 10 करोड़ से कम की बनाई तो भैया तुम्हारी मूवी फ्लॉप है, अगर 10 से ज्यादा की बनाई तो तुम्हारी मूवी हिट है. तो this is how decision tree works. That is why it is said कि this decision tree, मतलब this algorithm is suited for number of मतलब for any data set, okay, but provided it should be a medium data set. It shouldn't be a very large data set. And one of the major problem with decision tree is that the overfitting problem is very probable here. Okay, it is very rapidly it gets overfitted. तो ये एक सबसे बड़ी दिक्कत आती है यहाँ पे. But we have a number of methods to do it while fitting the data. We have number of methods how to fit it. Okay, I'll just tell you. Okay, but yes, the second split is based on what? It is the estimated budget while making the films. Okay, it is the estimated budget while making the film. So this is my second split and this is my first split. Okay, this is my second split and this is my first split. ठीक है, अच्छा, अब बात आते हैं, here the data is clearly visible. ठीक है, here the data is clearly visible. अगर ये केस आता, if this is the case, तो भाई तुम लोग कर ही नहीं पाओगे. I hope you are getting this. अभी तो दो फीचर थे, मान लीजिए I have two features. If I tell you भैया you have 100 features, क्या आप सोच भी सकते हो रैंडमली मैनुअली डेटा को स्प्लिट करने का? कभी भी नहीं. यू कैन नेवर थिंक ऑफ स्प्लिटिंग द डेटा रैंडमली इफ यू हैव मोर देन 2 फीचर्स, बिकॉज यू वोंट बी एबल टू रियलाइज, यू वोंट बी एबल टू एक्चुअली विजुअलाइज कहां से मुझे क्या करना है. So there what happens is there the algorithm would play its role. Okay, there the algorithm would play its role. So abhi to randomly I just wanted you to understand, to randomly I just divided, but where we have more than, I mean where the data is complex. See here I have two features x1 and x2, but the data is really very complex. So I have to make how many splits? Split 1 2 3 4 to homogenize. Okay, to homogenize a certain category. But if the data is complex or features are very high, तो आप सोच भी नहीं सकते कि फ्रॉम वेयर टू स्प्लिट, फ्रॉम हाउ टू स्प्लिट, कहां स्प्लिट कर सकते हैं, कभी भी नहीं हो सकता. ओके, तो देयर व्हाट एग्जैक्टली वुड डू इज देयर दिस एल्गोरिथम वुड प्ले इट्स रोल. ओके, तो देयर दिस एल्गोरिथम वुड प्ले इट्स रोल. अब आप मेरे साथ यहां पर एक बार डिसीजन ट्री देखो कैसे बनता है, हाउ डिसीजन ट्री इज मेड. For the previous example, okay, for the previous example which had 30 movies, okay, the previous example I had how many movies? I had a total of 30 movies in the data set. Okay, I had 30 movies in the data set. Okay, now what I have done, I have basically firstly splitted the data set. Okay, this is what? This is my first split. Okay, this is what? This is my first split. So I firstly split along what? Along the number of celebrity. Okay, so I have to set some average. This low is how much, this high is how high, this low is how high. तो कोई बात नहीं, वो बात की बात है, but the point should be clear to you. ठीक है, I can just select number of celebrity. For example, this could be 2, less than 2, more than 2. So how this number comes, I'll tell you. Okay, while describing the algorithm, I'll tell you. Just don't worry about that. Okay. So this is what? This is number of celebrity. So if celebrity is less than 2, just for an example, if it is less than 2, so you would be getting 1 critical success. I mean, in this split, how many critical success you have? 1 critical success, 1 mainstream hit, and 10 of 12 box office bust. Okay, so a total of 10 plus 1 plus 1. So total of 12 movies are there. A total of 12 samples are there while splitting along number of celebrities. Okay, so that means this split is good or not. If you want to judge whether this split is good or not, that I would tell you how to judge it. Okay, that I would tell you how to judge it. Whether this split is good or not, that I would tell you how to judge it. But after splitting, this is the case where in the first split I have 1 critical success, 1 mainstream hit, and total of 10 box office bust. So I hope you are able to judge. I hope you are able to judge that I have actually homogenized after first split. Some of the data is actually homogenized after first split, where 10 movies are flop. फ्लॉप मूवीज मैंने अलग कर ली कि भैया अगर तुमने इससे कम हीरो हीरोइन लिया तुम्हारी मूवी फ्लॉप बनेगी. दैट आई हैव सेपरेटेड. ओके, दैट आई हैव सेपरेटेड. टू दिस आई हैव सेपरेटेड. अलॉन्ग विद दिस आई हैव 1 क्रिटिकल सक्सेस, 1 बॉक्स ऑफिस बस्ट. बट ठीक है, दैट इज फॉर श्योर, नो वरीज कि भाई आपको तो पता ही है यार कि नो एल्गोरिथम इज 100% एक्यूरेट. तो हाउ कैन यू एक्सपेक्ट दैट दिस होमोजेनाइजेशन वुड बी 100% एक्यूरेट. कोई बात नहीं, करते रहेंगे, बार बार करते रहेंगे, तो डिसीजन ट्री में भी कुछ ना कुछ एरर आ जाएगा, कोई बात नहीं. तो ठीक है, तो दिस इज हाउ माय फर्स्ट स्प्लिट वर्कड. तो इफ यू वांट टू सी इट इन द डिसीजन ट्री, तो दिस इज हाउ यू कैन सी इट. If you want to see in the decision tree, this is how you can see it. So for example, if this is less than 2, this is greater than 2, so this is how it would be look like. Okay, this is how it would look like. Okay, now this would tell me that I can have a box office bust, matlab class label. This is the class label. Okay, this is the class label. So I obtained this class label here. So if I am splitting it at number of celebrities less than 2, majorly I would be getting this class label. Okay, majorly I would be getting this class label. If I split the movies, if I split this whole data set, okay, so greater than 2, I have 9 critical success movies and 9 mainstream hit movies. So total 18 samples are there. Okay, total 18 movies or 18 samples are there, and out of those 18, total 9 critical success, 9 mainstream hit are there. ठीक है, अब what I'll do is I would again do a split. Where on what I would do a split? This is my second split. Okay, again I would do a split. Okay, on what I would do a split? I would do the second split on the budget. Okay, where I would do the second split? I would do the second split on the budget. So when budget is high, just see here, when budget is high, matlab this is the second split. So when budget is high, I obtained how many mainstream hit movie? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I obtained 9 mainstream hit movies. Okay, I obtained 9 mainstream hit movies. So there, when budget is high, I have single critical success and 9 mainstream hit movies. That means what is this class label? I reached a class label that is known as mainstream hit. Okay, that is known as mainstream hit. This is the class label. And if the budget is low, I again reached a class label that is known as, that is critical success. This is again a class label. Okay, this is again a class label. Okay, so this is the basic funda. This is the basic funda of partitioning or splitting the data against any feature. Okay, this is the basic funda of partitioning the data against any feature. I hope this concept is clear to you. थोड़ा थोड़ा समझ में आया होगा. I want likes from your side. Okay, Please, I want likes on the main channel from your side. Okay guys, if you understand, just give me a bit of motivation, give me likes, no? Okay, chaliye. अब after this, after this, now firstly understand the bit introduction. Let us see the bit introduction of this algorithm. So it was developed by 𝐂𝐸𝐴 and improved version of his prior algorithm, that is C4.5. okay, this algorithm is C4.5. okay, so if at all it comes no C4.5 or ID3, तो इसका मतलब यही होता है. okay, if at all algorithm comes as C4.5 or ID3, that means the same. okay, that means the same. तो if at all this algorithm, अगर question में आता है, if at all question comes no, you have to solve this using ID3 or C4.5, that means you have to apply decision tree. okay, चलिए, तो this is 4.5 ID3 and it uses cart method. okay, तो just remember, okay, it uses a cart approach. What is cart approach? Classification and regression tree approach. okay, so this is what, this is a classification and regression tree approach. okay, classification and regression tree approach. okay, so this uses a cart approach, classification and regression tree approach. okay, so ab whenever you make a decision tree, okay, whenever you make a decision tree, it is the top node. okay, the top node where all the movies were accumulated. okay, so for example, all the movies, 30 movies were there, no? So in the top node where we had 30 movies, okay, so this is, that node is known as root node. okay, so where all the movies were there, that node is known as root node. ठीक है, where all the movies were there, that node is known as root node. Then after splitting, these are known as internal nodes and this is branches. And in the last where we reach class labels, in the last where we reach class labels, that is known as leaf nodes. okay, those are known as leaf nodes. So I'll just tell you here that, for example, this is the root node. okay, this is what, this is the root node. okay, this is what, this is the root node, right? This is what, this is known as internal node. okay, this is known as internal node. okay, acha, this is what, this is branch. okay, this is branch. okay, and this is what, this is class label. okay, so this is leaf node. okay, this is leaf node. So guys, just make it a diagram and just write all these things. okay guys, I request everyone, please make this, everyone. Okay, चलिए अब now अब now let us focus something uh, on how to decide the root node, leaf node and decision node. Okay, so that means along which feature I should split. Okay, that how to decide. Either I should split first along the number of celebrities, or either I should first split along the budget. No, so which feature I should split along, how to decide that. Okay, so now the next topic would be feature selection. Okay, so next topic would be feature selection. Okay, next topic is what? This is feature selection. Okay, so what exactly feature selection is? It decides along which node to split. Okay, it decides along which node to split. Okay, it decides along which node to split. Okay, so what should be the first best split node in the training data set? Right, so this is done on the basis of two measures, right? Feature selection is done on the basis of two measures. The first one is information gain measure. Okay, so it is done on the basis of two measure. It is done on the basis of two measures. ठीक है, तो इसमें जो पहला जो measure है, the first measure is the information gain measure. Okay, the first measure is information gain measure and the second measure is Gini gain measure. Okay, the first measure is information gain measure and the second measure is Gini gain measure. Okay, so let us start with information gain, right? Let us start with the information gain measure. Okay, let us start with information gain. Okay, now information gain, we have to calculate entropy first. Okay, so for calculating the information gain, we have to calculate entropy first. I'll just write IG here. Okay, I'll just IG here. So IG is inversely proportional to entropy. Okay, IG is inversely proportional to entropy. Okay, information gain is inversely proportional to entropy. Okay, and the formula for entropy, you just write, I'll calculate it, no, using number of questions we'll calculate this. The formula for entropy is given as minus of probability of positive class. Okay, minus of probability of positive class into log 2 positive class. Okay, minus probability of negative class into log 2 negative class. Okay, so this is for a binary class data. Okay, so this is for a binary class data, right? So this formula for entropy is for a binary class data. Okay, this formula for entropy is for the binary class data, right? And what is P? P is the probability of a certain class. Okay, I'll just define P. P defines the probability of a certain class. Probability of a class. Okay, that is P, probability of a class. Okay, that is P. And how to define entropy for a multi-class data set? So I'll just write entropy for a multi-class data set. Okay, entropy for a multi-class data set, that is summation of, yeah, negative of summation of Pi log to Pi. Okay, Pi log to Pi. Okay, so where what is Pi? Pi is the probability of class I. Okay, what is Pi? Pi is defined as probability for class I. Please no please, I mean, just help out there, no, for the persons who are not able to open the notes, no, please help out there, just provide the link of that. It is actually there. Okay, Hemlata, that is there in the comment section, no, there you can just find the PDF of that. Okay, the link is, the drive link is there. Please someone provide the drive link. Okay, chaliye, now after this, yes, if you could mail, no, please write your email ID. I think the persons can mail you. Okay, chaliye. Now next is, I'll just like to draw the graph and explain what does this entropy means. Okay, I'll just like to draw the graph of what exactly this entropy signifies. Okay, and what exactly the entropy means. Okay, so if I just draw a graph of entropy for for a binary class data set, no, so it would look like this, where x-axis, where what is x-axis? X-axis is, where what is x-axis? It is the probability of class labels. Okay, it is the probability of class labels. Okay, and what is y-axis? And what is y-axis? Y-axis is the entropy. Okay, y-axis is the entropy. So when probability of class label is pure 0 or pure 1, then entropy is 0. Okay, and when the class label, is 50%, it is a mixture of 50% of class 1 or 50% of class 0 and 50% of class 1, their entropy is maximum. Okay, their entropy is maximum. So basically, where entropy is maximum? When we have a mixture of class 0 and class 1, their entropy is maximum. Okay, when we have a mixture of class 0 and class 1, there the entropy is maximum. Okay, so you should understand this, that entropy is maximum when we have a mixture of class 0 and class 1. Okay, so in this data set, I would just like to ask you, in this data set, what would be the entropy of this root node? Okay, what would be the entropy of this root node? If I want to compare the entropy of this root node and the entropy of this internal node, which entropy would be higher? Yes, I hope you are able to identify that entropy of this root node would be higher than the entropy of this internal node. Okay, because the mixture, this data set is highly mixtured, that is a heterogeneous mixture. I hope you are able to understand this, no? Because this is a heterogeneous mixture of critical success, hit and flop movies. Here we tried to homogenize the mixture, so that means the entropy of the root node is much higher. Entropy of the root node is much higher than the entropy of the internal node. So basically what entropy is, it gives us what? An identification or determination of what? Of how the homogenized mixture is. Okay, so it gives us the identification of how the heterogenized or homogenized the mixture is. Okay, the data set is. Okay, the data set is. So that is what the entropy signifies. Okay, so for example, I have two data sets, right? For example, I have two data set. Okay, this is target variable y, and this is the target variable y for data set second, right? We have two data sets, right? We have two data sets. So this is data 1, okay, and this is data 2, right? And for example, the target, for example, we have 5 samples: sample 1, sample 2, sample 3, sample 4. Okay, 4 samples are there in both the data. Okay, sample 1, the class label is male. For sample 2, class label is male. Sample 3, class label is male. Sample 4, class label is female. Similarly, for data 2, class label 1, sample is male. Class label 2, sample is male. Class label 3, sample is female. Class label 4, sample is female. I hope you are easily able to see that entropy of second would be greater than the entropy of first. I hope you are able to see that entropy of second, that would be greater than the entropy of 1. Okay, entropy of 1. And I think you can see here that entropy of the data second, entropy of data second is equals to 1. Okay, entropy of data second is equals to 1, because we have a perfect mixture of class 1 and class 2. Okay, we have a perfect mixture of class 1 and class 2. Okay, we have a perfect mixture of class 1 and class 2. We have a perfect mixture of class 1 and class 2. Okay, so here entropy is 0. Okay, so at class 0, here entropy is 0, and when we have a pure class 1, here entropy is 0. But at this position, entropy would be 1. I hope now this picture of entropy is clear to you. I hope now this picture of entropy is clear to you. Okay. Okay, so if this is clear, then try to solve one numerical for me. So this is the data set, okay, and you have total of 6 samples, and it is a binary data set, and you have to calculate the entropy of the entire data set. Okay, so you have to calculate the entropy of the entire data set. Okay, please do this for me. Please calculate this for me. I'll wait for 2 to 3 minutes. I want you to do this question. Yes, correct. Vishal, correct. So entropy means randomness of the data points. Okay, Shagufta, I hope now this is clear, beta. It is what? It is the randomness of the data set, how heterogeneous the mixture is. For example, here I have a mixture of class 0 and 1 with equal amount. Here entropy is at its peak, that is 1. Okay, so this is a much random mixture. Okay, here the randomness is very high, but here randomness is very low because we have a homogeneous mixture. Okay, Vishal and Shagufta, I hope this is clear. Chaliye. So I'll wait for 5 minutes. I want you to do this question. Okay, just attempt it. Correct. 0.918 is correct. Yes. Ranjan is correct. Shagufta. Yeah. Both of you are correct. Vishal, just check once more. Just check once more. How to do this? Very simple. See how to do this. You have this data set where the probability of the, see, we have two classes. Okay. So class 1 is female and the next class is male. Okay. Class 1 is female and the next class is male. So what is the entropy of the data set? Oh, sorry, probability of the class female. So probability of class female is how much? Yeah, I'll just calculate the probability of class female. The probability of class female is 1, 2, 3, 4. So 4 out of 6. And what is the probability of class male? That is 1 and 2. Okay, that is 2 on 6. Probability of class male is 2 on 6. Okay, the probability of class male is 2 on 6. Now what we have to do, what we have to calculate, we have to basically calculate the entropy. The formula of entropy for binary class is what? Negative of p positive log to p positive and negative of p negative log to p negative. So you just have to use this. Negative of 4 by 6 log to 4 by 6, negative of 2 by 6, okay, log to 2 by 6. So you would be getting 0. I'll tell you the correct answer, 918. Okay, this is the correct answer, 0.918, right? This is the correct one. Okay, 0.918 is the correct one. Okay, now next question. Now next question is that you have this sample set. Okay, you have this sample set, data sample, and you have to calculate the entropy of the data set. Okay, entropy of a fever attribute, value equals to high, and entropy of cold, this is cold attribute. Okay, this is cold attribute, value equals to mid. Okay, so firstly calculate the entropy of the entire data set. Okay, firstly calculate the entropy of the entire data set, right? So how to calculate the entropy of the entire data set? So you have a total of 7 samples where how many yes are there? 1 yes, 2 yes, 3 yes, 4 yes, 5 yes. Okay, so what is the probability of yes? That is 5 by 7. And what is the probability of no? What is the probability of no? That is 1 no and 2 no. Okay, so that is 2 by 7. So probability of yes is 5 by 7 and probability of no is 2 by 7. Okay, chaliye. Ab after finding the probability, what is the entropy of the entire data set? So entropy of the entire data set. So I would just write this by E of S. E of S means what? That is the entropy of the entire data set. Okay, what is E of S? That is the entropy of the entire data set. So that is how much? That is 5 by 7 log to 5 by 7 minus 2 by 7 log to 2 by 7. Okay, so calculate the value of this, how much it would come. So it would be around 0.86. Okay, this is the entropy of the data set. Okay, that is around 0.86. Okay, now I hope you are able to see, no, this data is highly impure data. Okay, because that is close to 1. I hope you are able to see this data is highly impure data. Okay, this data is highly impure data. Now I have to guess, or I have to determine about which feature I should split. Either I should split along feature fever, or I should split along feature cold. Okay, yes, Vishal, correct hai beta. Vishal, correct. 0.864 is exact answer. Okay, now I have to, yes, Uddhav is also correct. Okay, now I have to just guess along which feature I have to split, whether I should split along the feature fever or cold first. I mean, which should be my best split node. Okay, now I have to decide which should be my best split node. Okay, I have to decide which should be my best split node. So for deciding the best split node, what I would do is I have to calculate information gain. Okay, now just write the formula for information gain. So for calculating the best split node, I have to calculate the information gain for every feature. Okay, so information gain for feature 1 is calculated as entropy of the entire data set minus average entropy of feature 1. Okay, so this is how the information gain is calculated. Okay, and what is this average entropy? This is the weighted entropy. Okay, this is the weighted average entropy. Okay, this is the weighted average entropy. What is this average entropy? That is the weighted average entropy. Okay, अब now let us calculate information gain for feature. Okay, now calculate the information gain for feature fever and calculate the information gain. Now calculate these two things for feature information gain for feature cold. Okay, तो जिसका भी इंफॉर्मेशन गेन ज्यादा होगा, ओके जिसका भी इंफॉर्मेशन गेन ज्यादा होगा, दैट फीचर आई वुड अगेंस्ट दैट फीचर आई वुड बी स्प्लिटिंग माय डेटा. ठीक है, अगेंस्ट दैट फीचर आई वुड बी स्प्लिटिंग माय डेटा. ओके, तो नाउ लेट अस कैलकुलेट द एंट्रोपी फॉर फीवर एट्रीब्यूट वैल्यू फॉर द फीवर एट्रीब्यूट. ओके, तो yes, अब now for fever, now let us see how to calculate this. Okay, I'll just tell you. For fever, I'll just make a table. I'll just make a table here, or this table here. Yeah, so I have feature fever. How many highs are there for feature fever? How many highs are there? 1 high, 2 high, 3 high, 4 high. Okay, so for feature fever, how many highs are there? We have 4 highs. And how many lows are there? We have 1 low, 2 low, 3 low. Okay, so we have 3 lows. So for feature fever we have 4 highs and 3 lows. Okay, for feature fever we have 4 highs and 3 lows. And for these 4 highs, how many yes are there? I have 1 yes, 2 yes, 1 no and 3 yes. So for this I have 3 yes and 1 no. Okay, I have 3 yes and 1 no. And for the class low, how many yes and no are there? For class low I have 1 no, for class low I have 1 yes, and for class low I have 2 yes. 2 yes, 1 no. Okay, so I have 2 yes and 1 no. Okay, I have 2 yes and 1 no. Ab now I would be calculating the entropy. Okay, I would be calculating the entropy for fever attribute with value high. Okay, I would be calculating the entropy with fever attribute with value high. So how many yes and no are there? 3 yes and 1 no are there. So what is the entropy? Minus 3 by 4 log 2 3 by 4 minus 1 by 4 log 2 1 by 4. So this I have to calculate, and I have to calculate the entropy for the attribute fever with value low. For value low, how many yes and no are there? I have 2 yes and 1 no. So that means negative of 2 by 3 log 2 2 by 3 minus 1 by 3. Okay, log 2 1 by 3 minus 1 by 3 log 2 1 by 3. Okay, so guys just calculate this, how much it is coming, calculate it. So how much that is coming? Correct, 0.8112. Okay, so 0.8112, 0.918. So this is 0.8112 and 0.918. So what is the average entropy? What is the average entropy of the fever? Yes, Udhav, what is the average entropy of the fever? So how to calculate this? So for average entropy of fever, so how many highs are there? We have 4 highs and 3 lows. So average entropy is calculated by 4 by 7 into 0.8112 plus 3 by 7 into 0.918. Okay, so 4 by 7 into 0.812 and yeah, 3 by 7 into 0.918. Okay, so guys, just calculate it. It would be, yes, it is 3 by 7 only. I think actually you are getting it wrong, no? This is 3 by 7. Correct. So you would be getting around 0.8544. Okay, so you would be getting an answer about 0.8544. Okay, so you would be getting 0.8544. So this is the average entropy of fever. Okay, so you are getting 0.8544. Okay, 0.8544. And similarly we have to calculate this, and similarly we have to calculate. Okay, so yes, so now what is the information gain? Yes, so what is the information gain for fever? Yes, Ig for fever. What is the information gain for fever? So that is 0.86. What is the entropy of data set? 0.86 minus 0.8544. Okay, yes, Uda, what is the answer? 0.86 minus 0.8544. Okay, 0.86 minus 0.8544. Okay, yes, Veda, it is there in the description, beta. It is there in the description. You just check the description. You would be getting the drive link of every subject, no? Of every subject, right? You just check in the description. Every subject is there. Okay. Okay, so you would be getting 0.056, right? So this is the information gain. This is the information gain for the attribute fever. Okay, this is the information gain for the attribute fever. Yes. Okay, point kitna? 0.00. Yes, 0.0056. Okay, 0.0056. Yeah. Okay, just check this. 0.0056, I guess. 0.0056. Okay. Okay, and similarly calculate information gain. Calculate information gain for the attribute cold. Okay, so now for calculating information gain for the attribute cold, let us make again this aggregation. No, so cold has how many? Okay, I'll just rub it, right? I'll just rub it. I'll do this again, this practice for cold. Okay, I'll just do this practice for cold, right? So cold has how many mid and highs? So when cold is mid, 1 mid, 2 mid and 3 mid. Okay, and 4 highs. Okay, so we have 3 mid and 4 highs. Okay, we have 3 mid and 4 highs. Now for mid we have 1 yes, we have 2 yes and we have 3 yes. Okay, so for mid we have 3 yes and 0 no. Okay, and for high we have 1 no 1 yes, 1 no 1 yes. So that means 2 no and 2 yes. Okay, that is for the feature cold. Okay, that is for the feature cold, right? That is for the feature cold. Now very simple no. So I can just calculate this for feature cold. So for feature cold is entropy. Okay, so entropy for feature attribute for feature cold when value is high. Okay, acha, ab if you just see here, very simple, I can just calculate. When it is high, I have 2 no, 2 yes. It is a highly impure mixture. For a highly impure mixture, what is the value of entropy? I hope you are able to get this. Highly impure mixture value of entropy is 1. Okay, and for the feature cold value mid. Okay, for the feature cold value mid, you can just see that is a highly pure mixture. 3 yes, 0 no. If I have 3 yes, 0 no, what is the value of the entropy? Very simple. Value of entropy is 0. Okay, so what is the average entropy? Average entropy for the feature cold, that is how much? So how many highs I have? I have, yes, how many highs I have? I have 4 highs. Okay, so 4 highs. So 4 by 7 into 1 plus 3 by 7 into 0. So I would be getting an answer of 4 by 7. Okay, so what is 4 by 7? .5714. Okay, so that is 0.5714. That is the average entropy of the feature cold. Okay, average entropy of the feature cold. Again I would explain, very simple. See, I told you, when I have a pure data set, see here, I just told you, whenever I have a pure data set, for example, only class 0 is there, only class no, only class 0, that means entropy is 0 there. When I have a pure mixture, okay, impure, a highly impure data set, 50% class 0, 50% class 1, what is the entropy? Entropy is 1. Similarly, if you just see here, I have 3 yes, 0 no for class mid. That means what is the entropy? Entropy is 0, because that is a highly pure, that is a pure mixture, that is a pure one. Okay, and 2 yes, 2 no, that is a highly impure one. That means entropy would be 1. Okay, so I would be getting 0.5714. Now what is the information gain? What is the information gain for the feature cold? What is the information gain for the feature cold? Very simple. So what is the entropy of the data set? Okay, entropy of the data set is 0.86. Okay, already we have calculated entropy of the data set, that is 0.86. Okay, so 0.86 minus 0.5714. Okay, so that is how we have to calculate. Okay, Ranjan, I hope beta this is clear. So entropy of data set is 0.86 minus 0.5714. Okay, so from here I would be getting information gain. Kitna aa jayega? Just calculate information gain for the feature cold. Correct, 0.2866. correct, 0.2866. So now you tell me, against which feature I should split it first. Now you only tell me against which feature I should split it first. Either it should be against the feature cold, or either it should be against the feature fever. Now you only tell me which should be my, what should be my best split. Okay, which feature should be my best split? So is it fever or the feature cold? So the feature which has higher information gain, since the information gain for the feature cold is greater than information gain for the feature fever. So that means my best split node would be, what? That means my best split node is what? it is the feature. Okay, my best place node is what? It is the feature cold. Okay, that is the feature cold. Definitely. I hope आपको पिक्चर क्लियर हो गई होगी. आई होप द थिंग्स आर क्लियर टू यू रिगार्डिंग डिसीजन ट्री, हाउ टू सॉल्व इट, व्हाट शुड बी द अप्रोच. ओके, definitely look once again this video if at all there is any doubt and solve this question, right? So this is correct. This is all regarding the information gain. Okay, so this is all regarding the information gain. Now you can easily answer these questions. What is the entropy of a fever attribute value equals to high? Very simple. 2 मिनट का क्वेश्चन है आपके लिए. एंट्रोपी ऑफ अ कोल्ड एट्रीब्यूट वैल्यू इक्वल्स टू मिड. भाई बहुत सिंपल है, 2 मिनट का क्वेश्चन है आपके लिए. इजीली यू कैन डू दिस. ओके, अब आफ्टर दिस आई एम गिविंग यू सर्टेन homework. So you have to do this question as the homework. Okay, you have to do this question as the homework. Then you have to do ये भी होगा डाइट इट. करेक्ट, इस क्वेश्चन को भी आपको होमवर्क करना है. Do this question as homework. Okay, करेक्ट. अब बस आपको हाँ मैक्सिमम गेन दिस बेस्ट स्प्लिट नोड एंड दिस क्वेश्चन एज होमवर्क. ओके, calculate gain. Okay, this question as homework. So do this question as homework. Okay, correct. Then इसके बाद tomorrow we would be starting with the Gini gain. ठीक है, तो इससे पहले वाला भी होमवर्क कर लो. This also you can do this as homework. तो I have given you 4 questions. Okay, for homework. और tomorrow I would be starting with Gini gain measure. ठीक है, tomorrow I would be starting with Gini gain measure. Okay. हाँ, correct. Yes, now I would just come to that cost function. No, correct. I would now come to this cost function. हाँ, basically see the cost function is that is the cross entropy loss. Okay, in case of logistic regression, तो the cross entropy loss is known as the cost function. अच्छा, आप मुझे बताओ what was the cost function in case of linear regression? In case of linear regression, cost function was MSC. है ना, कॉस्ट फंक्शन वाज एमएससी. तो एमएससी क्या होता था? मीन स्क्वायर एरर होता था, है ना. अब यहां पर जो क्रॉस एंट्रोपी लॉस है दैट वुड बी द कॉस्ट फंक्शन. फॉर्मूला वी वुड बी स्टडिंग दिस इन द न्यूरल नेटवर्क. ठीक है, तो आप थोड़ा सा वेट करो बेटा, है ना. न्यूज बस्टर आप थोड़ा सा वेट करिए. वी वुड बी स्टडिंग दिस फॉर्मूला इन न्यूरल नेटवर्क्स. डिटेल में हम वहां पर करेंगे. बस आपको भी याद रखना है कि जो क्रॉस एंट्रोपी लॉस होता है दैट इज द लॉस फंक्शन. ओके, और दैट इज द कॉस्ट फंक्शन इन केस ऑफ लॉजिस्टिक रिग्रेशन. ठीक है, तो ये आप थोड़ा सा वेट करो. अब यहां पर न्यूरल नेटवर्क आएगा इन अनदर 3 और 4 days वील बी डूइंग दिस. ठीक है, डन 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 डन. चलो ठीक है बेटा, है ना. तो आई विल एंड इट एंड प्लीज डू दी होमवर्क फॉर टुडे एंड लेट अस मीट टुमारो. ठीक है, चलिए, ऑल द वेरी बेस्ट. थैंक यू सो मच फॉर योर कोऑपरेशन.